When it comes to thermal conductivity testing, direction matters. Heat doesn't always travel the same way through a material. Its path depends heavily on the structure and composition of the sample. By understanding this directional behavior, engineers and scientists can make better material and design choices. Whether you're testing insulation, thermal interface materials, or advanced composites, knowing when to measure through plane versus in plane can make all the difference. So, what is the difference? In through plane measurements, heat flows perpendicular to the surface, straight across the thickness of the sample. In contrast, in plane measurements capture heat flow parallel to the surface, spreading laterally across the material. This distinction is especially important for anisotropic materials like laminate, composites, and films, which behave differently depending on the direction. Choosing the wrong geometry can result in misleading data and, ultimately, poor design decisions. So, how do you choose the right geometry? Consider the material's structure, the application needs, and the desired and used performance. Is your sample isotropic or anisotropic? Do you need vertical heat transfer or lateral heat spreading? And will your material act as a thermal barrier, or will it distribute heat across the surface? Through plane measurements tell us how heat moves across the thickness of a sample. They're ideal for testing thermal interface materials, packing materials, and multi-layer composites where vertical transfer is critical. In-plane measurements, on the other hand, show how heat spreads across the surface. This is vital when evaluating films, coatings, graphene composites, or heat-spreading layers in electronics. Accurate results depend on proper fixturing and preparation. For through-plane testing, align the sample perfectly with the sensor to ensure heat flows straight through its thickness. For in-plane testing, use insulative backing materials to guide heat laterally across the surface, such as in a TPS slab setup. In either case, the samples should have uniform thickness and smooth surfaces. Constant pressure must be applied throughout the measurement since poor or varying contact can significantly skew the results. Let's look at some real-world applications. Take a thermal interface material for CPU cooling. Here, heat must travel vertically from the processor to the heatsink. That makes through-plane testing essential to evaluating its performance. Now, think of a smartphone. Engineers often use graphene films or other advanced composites to spread heat laterally across the device. In this case, accurate in-plane measurements are critical. Here's a quick guide. Through plane, where heat flows perpendicular to the surface, best for thermal interface materials, insulation, and laminates. Ideal for measurements where vertical heat transfer matters. In plane, where heat flows parallel to the surface, best for films, coatings, and composites. Ideal for measurements where lateral heat spreading is needed. Using the wrong geometry risks misinterpreting thermal performance, leading to overheating, inefficient designs, or unnecessary over-engineering. Through-plane and in-plane measurements are more than just configurations. They're blueprints for understanding how heat really moves through your material. By matching the measurement direction to the application, you ensure reliable data, smarter design choices, and higher performing thermal solutions.